Mm. Hello, hello, Jigyasa, am I audible?
Yes, sir. Audible, sir.
Hello.
Sir, you are audible, sir.
Wait 1 second. Hello.
Sir, you are audible.
Okay, you are not audible. Wait 1 second. Okay, Jigyasa, yeah, I am audible, but you are not audible. Your voice is not coming. So, wait 1 second. I'm correcting it. Wait, I am resigning. Huh? Hello.
Yes, sir. You are audible.
Hello.
You're audible, sir.
Problem is still there. Okay, I'll start the class and in between I will see this. Okay. So today we will discuss week 11, which mainly covers vertical conveyor reaper. And in last week, week 10, we discussed about harvesting mechanism. We discussed mainly about uh, all the angles and in last week we discussed uh, about the cutting mechanism of crop crop failure also. So did you solve this assignment? You can write it here. I will
Yes,
see this.
sir.
All the questions you have solved. Okay. And today then we will start week 11. Here we will mainly discuss about vertical conveyor repair. So it mainly comprises of this feeding unit, cutting unit. This is the feeding unit. This part is the cutting unit. Then conveying unit. This is third one is the conveying unit. Then this is power transmission system. uh, Then propelling unit. Actually, the number in this figure has been, I think, it is inversed. This side it should be feeding unit. This is cutting unit. This part where in which we were discussing. Okay, that registration question I saw. It should be the answer should be it was question 6, I think. Uh, we discussed that the midpoint of the stroke is centered between adjacent guard, and that question is repeated this year also. But midpoint of the header shaft of the stroke is centered between adjacent guard is there. That is wrong. Header shaft of the stroke does not move. So you should just see that a stroke and adjacent guard should be in same should be centered. So that will be the correct answer. A stroke and adjacent guard should be centered. Means guards two guards are there. Between these two guards, the stroke should come. So that is the main point regarding registration. So that you can make correction. So in this vertical conveyor reaper, which is acronymed as VCR, it comprises of feeding unit. This is the feeding unit, which is here the numbering is wrong actually. Means one is not feeding unit. It is not matching. Feeding unit is this part, star wheel and this. So star wheel configuration mainly it should consist of like two governing factors are there, alpha and beta. Alpha and beta are these two angles. Like this is the like guard center part. You just make one horizontal line, this line. So this smaller angle is called alpha and this bigger angle is called beta. So this alpha and beta are the governing part in the star wheel. So this has been shown here. This is alpha and this is beta. And for proper feeding, it is it for convenience for proper cutting, alpha should beta should be greater than alpha. And the value of alpha and beta is generally taken as 12 degree and 16 degree with deflection of 50 mm between the center of the driver and center of star wheel. So next thing is for proper cutting, this criteria should be followed, where Vs is the average star wheel speed. Now this is a star wheel, its speed is support Vs, and Vm is the forward velocity of vertical conveyor reaper. This is moving forward with a velocity of Vm. So it should follow this relation. Alpha is the angle of inclination of a star wheel from horizontal. Alpha just we discussed. So this uh, this expression should be followed for proper cutting. This you can keep in mind. And next thing is cutting unit. For cutting unit, 76.2 mm stroke length should be there. Mhm. So selection of knife and knife back are made according to IS. These are the IS standards, and a reciprocating type cutter bar with 76.2 mm or 7.62 centimeter. The stroke is usually selected. Other points regarding the cutting unit. Now see, this is the main part. Like this is the main feeding unit, which it consists of this header shaft. This shaft is called header shaft. This which you are seeing. So its work is to convey and cut also. Like this will be used for conveying also and cutting also. So for cutting, this criteria should be followed. The length of lug conveyor chain is calculated based on length of cutter bar and length of vertical platform. And length of lug conveyor chain is denoted with this equation. This will not come in use. You can go through this formula. And next thing is pitch of lugs. Now the pitch of lugs of the conveyor chain is decided using this equation. Now this is an important governing equation for pitch of lugs, where this ds is the diameter of star wheel and pi is the pitch of the lugs, and ns is the number of arms of star wheel. So these criteria should be followed for deciding the pitch of lugs. And next thing is cutting and conveying. So that feeder shaft is uh, has to go through, means it should carry both cutting and conveying. So so this is the equation continuous continuous conveying of the crop. The conveyor output per unit time should be greater than plant steam cut by the cutter bar. So this is one factor which you can note down. The lug length should be such that bunches of cut crop can be conveyed continuously without any blockage. So these are the design criteria which should be taken care for designing this vertical conveyor reaper. And design of crop supporting unit also, like if you have seen the lectures, then these are our theoretical parts. And for power required for cutting, uh, we add this PF and PC, where PC is the cutting part and PF is for to overcome the friction. So and for conveying, just we discussed that feeder shaft has to convey also. So it will go through both this torque, torque acting on points A, B, and C will be there, and it will also be going with bending moment. So we can now solve some questions. Like this is the questions from last week 10. So first question is, which of the following equation is used for deciding pitch of lugs of the conveyor chain used in vertical conveyor? So you
D will
think
be
of
the
answer this
answer.
question. I will correct
D.
this mic issue.
So is my voice audible?
I'm rejoining you. Yes, Jigyas, can you say something? I know.
Sir, answer will be
No,
D.
not audible. Okay, leave. So yes, the answer you said that.
D answer I got. Like we
So
discussed it
this
today
criteria
only.
should be
Teacher
followed. Pi ds
will
should be equal to pi pitch into number of arms of the star wheel. So correct answer will be D. So next question is, which of the following correctly describes the relation among star wheel speed, Vs forward speed, Vm, and the angle of inclination alpha? Just now we have discussed this. So the correct answer is A. Vs cos alpha should be greater than Vn. Okay, that is correct. So third question is, which of the following statement is correct for vertical conveyor reaper? The lug length should be such that the bunches of cut crops can be conveyed continuously without any blockage. Just now we saw that this statement should, like this criteria should be followed for correct designing. And next is, for continuous conveying of the crop, the conveyor output per unit time should be greater than the plant stem cut by the cutter bar. So just now, by discussing conveying, we saw that for continuous conveying of the crop, the conveyor output per unit time should be greater than the plant stem to be cut by the cutter bar. And for that, this expression should be fulfilled. So second statement is also correct. Then belt speed for conveying cut crops should be greater than forward speed of the VCR. This is just a normal case for every harvesting equipment. Like the reel index also we saw in vertical conveyor reaper also conveying speed should be greater than the forward speed of the machine. And in just later we will discuss about top onion harvester. There also you can see. So yes, A and B was correct and C is also correct. So D, all of these will be correct. So next question is, which of the
Is
following
my
statement
voice
is not true
coming?
for the header shaft of an electric VCR? So which of the following is not true? So power is taken for operating the conveying belt. That is true. We saw that for conveying and cutting both it takes. So power is taken for operating the cutting unit also. It is taken by the header shaft of the VCR. So this two statement is correct. It is subjected to bending only. It is subjected to both bending and torsion. So this will be incorrect. So this is incorrect as it is subjected to both bending and torsion. So
B,
next
sir,
question is,
B.
a vertical conveyor reaper with a cutting width of 1.2 meter when operated at 1 kilometer per hour had a field efficiency of 75%. The effective field capacity will be. This is basic question which we see in BTech first year also, that what is effective field capacity. Effective field capacity or actual field capacity. Yes, you're saying 0.09. This one. Okay. So its formula is WC by or WS by 10. This will come in hectare per hour, and from here, if we multiply it by field efficiency, we can get actual field capacity. So W into speed, W into S. So W width is 1.2 meter into speed is 1 kilometer, and this divided by 10 into field efficiency is 0.75. So this will directly give you 0.09. So next question is, a single disc rotary mower has 4 blades and it rotates at 500 rpm. The mower is operated at a forward speed of 15 km per hour. To obtain a swath of 0.4 meter, the minimum required length of each knife. This is there in the lecture formula. Like this slide, I have not shown, I think, but there is an expression for minimum required length of each knife. L L is equal to 2 pi V by n omega, where V is the forward velocity, 15 km per hour. It should be converted in meter per second, and n is the rpm. Omega is the angular velocity. N is the n is number of blades here. More has 4 blades, so n will be 4. And omega you can calculate from rpm, this 500 rpm. So you can calculate this, like V should be in meter per second. So 15 into 15 by 3.6 you can do to get meter per second. N is 4 and omega is 2 pi n by 60. N is in rpm, so n by 60. So it will be 2 into 22 by 7 we can write into velocity is 15 by 3.6, 15 by 3.6, and is 4 into 2 pi n by 60. 2 pi is there. This is 2 pi. This is again 2 pi. And n is 500 to 60. Do this calculation. 2 pi v by n omega. This should be answered. Did you get any value? Jigyasu, did you get the answer? Yes, the answer is 12.5, means option A is the correct answer. So moving to next question. If rake angle and bevel angle of knife is in vertical conveyor reaper is 15 and 27 degree, the value of clearance angle in degree will be rake angle and bevel angle. Yes, just in last week we have discussed in detail about the angles. So this is rake angle, this is bevel angle, and rest this is clearance angle. So it will be 90 minus both the sum of both the angles. So 90 minus 55 plus 27. It will be 80. So A is the correct answer. Moving to next question, which is it is the spacing of guards in case of vertical conveyor reaper with a standard cutter bar in centimeter. So 76 and 76 should be the length of a stroke. So 76.2 or 7.6 in centimeter. So D will be the correct answer. So next question is in harvesting onion in with an onion topper cum digger, the speed of chain type conveyor is. So this is a common concept we are discussing since since we have started Reaper, that the forward speed of conveying should be higher than the forward speed of the harvesting unit. Yes. So D is the correct answer. And next question is the power required for harvesting onion with an onion topper cum digger includes the power required for digging, power required for conveying, power required for chopping. Everything will be used for power requirement for harvesting. So yes, D will be the correct answer. So these are the questions. Questions are simple only for this week 11 if you have gone through the video lectures, and these were some of the questions discussed in during the lecture class. So we can solve this also for better clarity of the topic. So if the forward velocity is Vf is 5% of the blade peripheral velocity of for rotary mower, determine the maximum oblique angle and blade angle at which it occurs. So for this, what you need to do, we have a formula for oblique angle. something v by v minus cos alpha. Some a formula like this for oblique angle is there. You need to differentiate both sides, and you will get, and you need to put like for maximum velocity you need to put forward velocity of 5% of blade peripheral for rotary mode, determine the maximum oblique angle and the blade angle at which it occurs. So while for by differentiating we can get, we will put 5% of the blade peripheral velocity, and we will get that we will get the maximum oblique angle. Uh, if you have seen the lectures, there it is solved. So it is like class 12 differentiation is there. So next question is estimate the power requirement for disc type rotary mower which has 6 discs with 4 blades in each disc and each cutting a width of 0.4 meter with overlap of 4% between adjacent discs. The blades are sharp and the travel speed is 15 km per hour. Assume the specific power loss as 1.5 kilowatt per meter of disc and the specific cutting energy of this. So you need to find the power requirement of disc type rotary mower. So in question number 6, minimum diameter of this. What is the exact question? Do you have the exact question? Because okay, can you share that? आवाज नहीं आता है। नहीं आ रहा। हाँ, कोई चलो, तो ऐसे ही ले रहे हैं स्टूडेंट से बारिश से। Single rotary mower has 14 blades and it rotates at RPM of 500. The mower is operated at 50 km per hour to obtain a shaft of 0.4 meter. The minimum required length diameter of this on the blades are to be mounted. Okay, first you need to find the minimum required length of each knife. Now, from here, there is some factor. Like if you have in lecture, sir has discussed that we need to multiply it with some factor to get the minimum diameter of this. So this I will see this and I will tell you through mail that there is some factor actually to with which we need to multiply. Four blades. Okay, this I will discuss later. So next question, which we were discussing is in question 2. Yes, this is same for vertical conveyor. This criteria should only be followed. Vs cos alpha should be greater than Vm. This we can like one question is also there. This is the question. A self-propelled vertical conveyor reaper is to be used for cutting wheat at a working speed of 1 km per hour. Assuming the inclination of a star wheel 30 degrees, outer and inner diameter, outer is 21 and inner is 16 centimeter. The number of arms on the star wheel at 7 in 10% slip rate. Find the velocity of a star wheel. So here that criteria will be applied, which is Vs cos alpha should be greater than Vm. So what will be the minimum star wheel speed? So we can use this equation. Vs should be equal to Vm by cos alpha, and this value will be the minimum speed, minimum velocity of the star wheel. So Vm is the forward velocity, that is 1 kilometer per hour. 1 by 3.6 meter per second by cos alpha. Alpha is the angle of inclination of a star wheel. So cos alpha is cos 30 degree. So this you put, so first answer will come. 1.7. Okay, 1.75 meter per second. This is the velocity of a star. Second question is pitch of lux on vertical belt. Pitch of lux criteria also which we discussed right now. What is that? Pi d should be IDS is equal to pitch into ms equal to pi into n. So d is the outer diameter of d is the assuming d is the outer diameter and p we need to find pitch of lux, and n is the RPM. N is the number of arms on the star wheel. Yes. So pi d is equal to pi pitch into number of arms. This you do. So pitch will be equal to pi d by n. 22 by 7 into diameter 21 into L is 1 by 7. So what will be the pitch? 9.4 centimeter. So third part is rotary speed of the belt pulley for moving the belt with diameter of driving pulley of the belt is 0.1. Rotary speed of the belt pulley. How to solve this?
Sir will multiply the
10% slip rate
10.1
between the
into
star wheel and light
1.75.
speed. So rotary speed of belt pulley will be 10% more than the velocity of this star wheel. So 10% of this velocity, more than this velocity. So third question is 1.1 into 1.75 meter per second. This is the velocity of belt pulley. So this this velocity is equal to pi 2 pi n by 2 pi n d. So from here we can find diameter, which is equal to 2 pi n by 60 into diameter. 2 pi into n is RPM is, and we need to find rotate speed we need to find, and diameter is given. So what answer you got? 1.925. Okay. So rotary speed will be 1.9 to 1.925 is for which part? 2 pi n into 0.12 by 60. This will come in RPM. So Belt speed should be okay. This is 1.92 meter per second. This is 1.92 meter per second, and this is 2 pi n by 60. From here you can get RPM. So 307 RPM. Now this is the question. These are the questions from uh, these are the questions from week 11. Next, you can solve this week's question, and if you get stuck like sixth question, you're saying, no? Which fact minimum required length of each knife? And this year they have asked that minimum required length of minimum diameter. So this I will discuss when I will see this and I will discuss it. So if you have any doubt from this week, you can ask it in the chat box.
Sir,
Mic is not working.
sir, if I am audible, am I audible now? Sir, am I audible?
If there is no question, then we will meet in next week.
Sir, am I audible now?
Okay, so now let us solve this question. This question is related to thresher only, and this is a very good question for your conceptual clarity. So the question says a raspa type thresher with cylinder diameter 45 centimeter has 6 bars. The concave subtends an angle of 100 degree at the center of the cylinder. So as we know that this is the concave, the cylinder is there, it is subtending an angle, it is saying that 100 degree. So the cylinder diameter is 45 centimeter at 6 bars. The concave subtends say 100 degree at the center of cylinder. Find out the frequency of radial vibration occurred by the crop mass for peripheral speed. So the peripheral speed Vp is 28 meter per second. We need to find out the frequency of radial vibration occurred by the crop mass. So cylinder diameter is given, number of Ras bar is given. This we did usually denote as Z. This is D. This is, if we write as U as peripheral velocity, and concave angle is denoted as alpha is 100 degree. So cylinder RPM will become U by pi d, or U into 60 by pi d if U is in meter per second. So RPM will be U is in meter per second, 28 meter per second into 60 by pi into D. D is 45 centimeter, and in meter it will be 0.45. So 28 into 60, 28 into 16 equal to 1680 by pi into 0.45. It is 1188 RPM. So 1188 RPM, which now we need to find the frequency of radial vibration. So the frequency of vibration occurred by the crop mass is determined by the number of bars passing through the concave area per unit time. So the formula for frequency is Z into N by 60. So Z is 6, N we have got as 1188 by 60. So this is 118.8 hertz. So this is 118.8 hertz. So this is the frequency. So this is the frequency of radial vibration. So this was very simple. Next question, I told you that we will solve this question next class. So the question is, a field displayer having a horizontal boom with 20 nozzles spaced 46 centimeter apart is to be designed for a maximum application rate of 750 liter per hectare at 520 kilopascal and 6.5 kilometer per hour. So first part is determine the required pump capacity in liters per minute, assuming 10% of the flow is bypassed under the above maximum condition. So in this question, now we have given parameters here, number of nozzles, which is 20, nozzle spacing is 46 centimeter, application rate is 750 liter per hectare, pressure is 520 kilopascal, forward speed is 6.5 kilometer per hour, bypass flow is 10%. So discharge rate per nozzle. First thing is we need to find the required pump capacity. 10% of the flow is bypassed. So for that, we first need to find the total liquid sprayed per minute. So first we will solve C part, then only we can solve the required pump capacity. Actually 10% of the flow bypassed. So C part is what is the discharge rate per nozzle. So for discharge rate per nozzle, we need to find the effective width. Effective width is 20 nozzle spaced at 46 centimeter. So width will be 20 into 46, which is equal to 9.2 meter. Area covered in meter will be 9.2 into its forward velocity, that is 6.5 into 1000 in meters by 60 will give meter square per minute. So it will become 996.67 meter square per minute. So total liquid spray per minute, that we need to find. Total liquid sprayed. Sprayed per minute. So this will become, we have 750 liter per hectare. So 750 liter in 10,000 meters square. And what area we have is 996.67 meters square in per minute. So this will become in meter per minute. So total liquid spray per minute will become 750 into 996.67 is equal to this by 10,000 is 74.75 liters per minute. This is the total liquid spray per minute. If we can denote it as suppose QT. Total liquid sprayed, so we can write it as QS. Now next thing is discharge per nozzle. So this is total liquid sprayed per minute by all the nozzles. So per nozzle discharge will be QS by number of nozzles. That is, I think 20. 20 nozzles. Discharge per nozzle they are asking. So discharge per nozzle is QS by 20. That is 74.75 by 20 liter per minute. So this is divided by 20 is equal to 3.73 liter per minute each per nozzle. Now we can solve first question, that is what is the required pump capacity in liter per minute assuming 10% of the flow is bypassed. So out of this is when 10% is bypassed, we are getting 74.75. So what was the original capacity? 70. Original discharge 7.47 by 0.9. So it is 83.05. So when there is 10% of the flow is bypassed, the nozzle represents 90% of the total capacity. So the nozzles are representing 90%. So what will be the 100%? 74.75 by 0.9, that is 83.05 liter per minute. So we are left with section B. So B part they're asking is, if the mechanical agitation requires 375 input watt, pump efficiency as 50% and transmission efficiency as 90%, what should be the engine rating if the engine is to be loaded not to more than 80% of its rated power? So what it is telling here is we need to find the engine rating. So first we will calculate what is the hydraulic power. So hydraulic power we have discussed earlier. Suppose Px is hydraulic power, then hydraulic power will be discharged into pressure, Q into P by 60. Or if it is in liter per minute and this is in kilopascal, then 60 into 1000. So discharge is 83.05 and pressure given is 520 kilopascal by 60 into 1000. This is 0.719 kilowatt. 0.1719 kilowatt. Now we will calculate the power required by the pump. So power required by the pump will be equal to this power, and pump efficiency is 50%. So we will divide it by 50%, that is 0.5, and it is 1.4. This is 1.4, 0.719 by 0.5. So 1.438 kilowatt. This is the power required by the pump. Total power at the engine shaft. So total power at the engine shaft, that is P total, will be equal to pump power by transmission efficiency plus agitation power by transmission efficiency. So this will give become total power. So pump power we have obtained as 1.438. It has to go through with transmission efficiency. So we will divide it by 0.9 plus agitation power. The question is given as 0.375 by 0.9. So this will become 1.38438 plus 0.375 by 0.9. So this is 2.01 kilowatt. This is the total power at engine shaft. So this is the total power at the engine shaft. We are asked what is the engine rating. So engine rating, engine should not be loaded more than 80%. So again, we will divide this engine power available at shaft by 80% to get the final value, final power, final engine rating. So engine rating, that is P engine, will become 2.01 by 0.8. As 80% is, it should not be loaded more than 80%. So final engine rating will be 2.01 by 0.8. It is 2.512 or 2.51 kilowatt. So this is the final engine rating. So I hope this question is clear. This was also very conceptual question related to the hydraulics or spraying part. So next I told you that we will discuss the design of whole spike tooth. Means we will discuss all the aspect of the design of a spike tooth thresher. So here design of spike tooth with thresher to handle 3600 kg per hour of feed stock. We will discuss. So for designing the spike tooth thresher, first thing, step one, we will determine the power requirement for threshing operation. So for this, we have discussed that for determining the power requirement, we use Goryatskin drum theory, which tells that the power is required to overcome the idle resistance. So power will be the sum of idle resistance, idle power and useful power. And idle power is given as AU plus BU cube. And in case of brass bar, A and B value we take as 5 and 0.045. There is a range, the table we have discussed in previous slides. So A value we will take as 5 Newton and B as 0.045. The referable speed should lie between 28 to 30 meter per second for threshing wheat crop. So we will take peripheral velocity as 28 meter per second. So AU plus BU cube will become 1.325 kilowatt. And next thing is power required to overcome the actual resistance, and that is given by m dot v square by 1 minus f. This we have derived in the previous slide. So we will directly use it here. M dot v is 3600 kg per hour. So it is 1 kg per second. V is 80% of 28 meter per second. So it is 22.4 meter per second, and F factor is 0.7. So and U will come as 2.09 kilowatt. So final power required for threshing will become 2.09 plus 1.32. So it is 3.416 kilowatt. This is the power required for threshing. Second thing is design of cylinder. So for design of the cylinder, we have seen that this is the formula for glass bar. So there are some assumptions here. And assumption is that length of cylinder usually lie between 1100 to 1750. So here we are taking 1200 mm length of cylinder, and it is denoted as LP. Diameter of cylinder should lie between 445 and 610 in case of a spike tooth, and 425 to 610 in rasp bar. So 450 mm we are taking the diameter of cylinder. Number of teeth in for permissible feed rate of 0.025 kg per second is 40. So we will put all those values in this formula, that is 40 is equal to our permissible feed rate MP into LP is the length by A plus 1. So here, from here, A will come as 97.31 mm. So A is nothing but the distance between adjacent pitch. So if you will design the cylinder and the sketch view you will draw. So this value, this distance is 97.31 mm. This is the length of cylinder. This is 1200 mm. Delta LP is left as margin here. This value is LP, delta LP, and pi d is the total circumference of the cylinder, which we will obtain as 1413.71 mm. So diameter of cylinder as 450 mm, the speed of drum as 28 meter per second. So RPM of cylinder will become 938 RPM. Next thing is design of a spike. For designing the spike, we have seen that the impact force is given as m dot Vy 1 minus f. So this force is working on one brass bar or one spike in case of weight pressure. So this we have seen that this, if this is the force acting denoted here as P, so we need to find what is the moment. What is the moment arm will be the length of this spike. So bending moment will be this force into that moment arm, and we will take factor of safety. So 3 as factor of safety, we will multiply 3 by 74, 3 into 74.67. It will become 2 to 4 Newton, and there are 13 things striking at a time. So for each knife, 17.23 Newton is acting. So this 17.239 and 23 acting at, suppose this 17.23 is acting at this distance, that is 0.06, so 1.03 Newton meter. And allowable stress of mild steel, if mild steel is the foundation of this spike, then 50 megapascal is the allowable stress. So we have seen earlier that sigma is equal to my by I. This formula we will again use it. I is pi d square by 64, m is 0.3 Newton meter, and y or c is d by 2. That will give d as 6, approximately 6 mm. So diameter of this spike will be 6 mm. Next thing is design of concave. For design of concave, which is below the cylinder, we need to know its length and the clearance. So periphery of the drum was coming as 1790 mm, and it spike and the concave periphery is taken as 1/3 to 5/12 of the drum periphery. So if you are taking 1/3 of the drum periphery, then it is 596 mm, and inlet clearance should lie between 16 to 18 mm, and outlet clearance, which is less than input clearance, is 4 to 6 mm. So we will take one value between 16 to 18 and 4 to 6, that is inlet clearance 16 mm, outlet clearance is 4 mm. Perforated area is to be kept 40% of total area of concave, and size of perforation depends on the grain size. The next thing is design of centrifugal blower. For designing the centrifugal blower, what we need is RPM of the blower. RPM of the blower will be same as RPM cylinder, as it is mounted on the same shaft as that of the cylinder. And from literature, it is found that 5 to 8 kg of air is required for 1 kg of chaff. Now assume grain to straw, standard straw to grain ratio is 60 to 40 and mass of straw in feed rate is 1 kg per second. So 0.8 kg, 0.6 kg per second we are giving the straw. Now 5 kg 5 kg air we are considering for 1 kg of chaff. So 0.6 kg per second, 3 kg per second of air will be required. The volume of air is 3 by 1.2, that is density. So 2.5 meter cube per second of air volume will be required. Terminal velocity of chaff is 10 meter per second and velocity of air is epsilon into peripheral speed of the blower. And it should not be greater than 18.18 meter per second. So velocity of air we will obtain from this uh, this empirical equation. So average diameter of the blade will become, if we are taking 18.18 as the maximum velocity, then velocity into 60 by pi into d. So average diameter of the blade will become 370 mm. Now this is average diameter. Now for outer diameter, outer diameter, the blower for blower it should vary between 470 to 720 mm. So taking one value that is 700 mm. So inner diameter will become 700 by minus 370 minus inner radius. That is inner radius will become 370 minus 350. 350 is the outer radius. So it will become, inner radius will become 20 mm. Volume of air handled. So 938 is the RPM and RO is outer diameter, RI is inner diameter, WB is width of this blade. So WB is width of this blade and blade RPM by 60. So this formula you will use and you can get 938 is equal to 5.996 WB. From here we can get the width of blade which is coming as 417 mm. Now total pressure acting on this blower blade will be static pressure plus velocity pressure. Static pressure is taken as 100 Pascal and velocity pressure is taken as half rho VA square. So VA we are taking as 19.18. So this will become 2001.61 Pascal. So total pressure will become 1201.6 Pascal. Considering the efficiency of blower as 70%, so power required for the blower will be 4.29 kilowatt. So finally we will add all the values of power, that is total power required will be power requirement for threshing, power requirement for blowing, and power requirement for operating the shaker. For threshing it was approximately 3.416 kilowatt. 3.416 kilowatt. For blowing, it is 4.29 kilowatt. And for shaker, you can assume some value, or you can design also. So you will add these three values and you will get what is the total power requirement of the thresher. So this was the design from scratch to end for the thresher. And we have concluded all the lectures of threshing, harvesting, spraying, seed drill, and all the tillage equipments. In next lecture, only combine harvester is left. Uh, so we will end the class here. If you have doubt, you can contact me on mail or you can write also in the comment section below. If you have any doubt, you can reach out. So thank you. We will end the class here.